Hey guys, welcome back to W.D.Y.D. CSP. What do you do as a central sterile processing technician? So, last video I went over medical terminology and anatomy in the manuals. Going forward, whether you're going through the issue manual or the CBSPD manual, it's pretty much linear as to the topics that they cover. So, chapter 4 is a chapter all by itself, which is microbiology. This is where central sterile processing technicians really need to understand how is it that we do what we do, why we do what we do, and how do we protect ourselves from the elements. So, the chapter has an overview of microbiology, beneficial and dangerous microorganisms, classifications and identifications of microorganism, controlling and eliminating, and then a conclusion. It's about a 25-page read. And if we go to chapter 4, which I'm going to go to right now, guys, I'm going to go there with you guys right now. So, chapter 4, as soon as I can find it, is very well laid out in both manuals. All right. The introduction to microbiology, of course, talks about who discovered it, what is microbiology. It's if you break it down, suffix prefix, micro meaning very small, biology meaning life. It's an ology is the study of microscopic life. They've been here since the beginning of time, before man, before any creation. They're still finding new bacteria and viruses every day. Take it, COVID-19, a new strain of virus, and there's many bacteria that evolved throughout the years. And um, if we talk about reproduction of bacteria, it's crazy how quickly they reproduce. Um, and we need to understand that when we're dealing with our instrumentation, um, because the longer an instrument sits contaminated, the more bioburden and the more um, challenge we have to clean it, because bacteria have certain properties, microorganisms have certain properties to sustain life. I mean, they adhere to surfaces, they create barriers to help them survive and lock in foods. Um, Basically, an overview of microbiology, they talk about, how they protect some bacteria protect the patients, like our natural flora in our skin, help ward off opportunistic bacterias and microorganisms. The bacteria in our mouth helps break down foods. Bacteria in our gut helps convert nutrients, things of that nature. Um, Most bacteria, all microorganisms cannot be seen by the naked eye. It's hard to see one bacteria, one virus, one fungi just by the naked eye. You need a microscope or some kind of enhanced, you'll hear that a lot, enhanced visualization in order to see them. They come in different shapes. They move around differently. You have rod shapes, you have cockle shapes, you have spiral shapes for bacteria. Um, they move in several different ways. They have flagella or celluli. Flagella is like a little whip-like tail that they use to move around. The celluli is like little tiny hairs, um, kind of like if you see on a hairy spider that's around a basically bacteria, and they use that to wiggle and move around. Um, Beneficial versus dangerous. Again, dangerous bacteria, those that cause harm, HIV, herpes, COVID, things of that nature, versus those that are beneficial to us, like the Staphylococcus or staph bacteria that we have, E. coli bacteria which is a natural flora in the human excretions and digestive tract. Those are actual beneficial to humans. Um, they do present benefits when they're in their correct area. Um, E. coli, when transferred from the digestive tract into the integrity system or into the into the oral cavity, does present a problem, okay, because they don't belong there. That's not their natural home. And when something in their natural home, they invade and they destroy, um, Pathogen is a terminology given to those microorganisms that causes harm or disease. Um, there are different states of pathogens, long term, short term, things of that nature. Um, Identification, again, I touched bases on that. Um, some have characteristics being aerobic or anaerobic. Aerobic means that they love air. Anaerobic is that they do not like air. They won't thrive in it, okay? Um, you have spherical shapes, which is spirals, almost like a spring. If you look at a spring from a pin end, okay, that can be like a bacteria strand, just one bacteria blown up into thousands of, microns so that we can visualize it. Spherical, like a pea, and rod shape, basically like a rod, a pencil, you know. They can be as long as that or as short, as stubby. Um, Bacteria is usually clumped together. Okay, they come in chains. Very few are singular, and you start talking. So spherical is. Sorry, I'm kind of rambling on here, but I'm trying to read here and recollect some of this stuff. So, spherical bacteria, shaped like a circle or spears. Okay, they're called coccus. Okay, such as Staphylococcus aureus. Okay, rod shape, which is bacillus, and spherical is spirilla, like Helobacter pylori is a spherical bacteria. Bacteria in their vegetative state or their inactive state go into a form called endospores or spores. That's where it's a resting stage or a protective stage of bacteria. They are the hardest and most difficult to get rid of and kill because of their tough outer shell. Um, and those are what we use to validate and verify the efficacy of our sterilizers. We use spores to verify that the sterilizer is doing this thing, but that's in a later chapter. Um, Bacteria and microorganisms are living things. They are alive. They're not dead. Okay. Um, they have certain components to them, a nuclei, they have DNA, they have a cortex, they have ribosomes so that they can reproduce. Um, we identify them by several means. There are what we call gram stains, gram positive, gram negative, to identify the strain of bacteria. The gram negative bacteria are the ones that present sterile processing in healthcare the biggest challenges because they're very stubborn, and most of them are pathogenic. You also have what's called the Zeo-Nielsen stain or the acid fast staining for some bacteria that do not take well to the gram staining. And again, gram was named after the discoverer of the procedure to identify him, Alex Graham. Um, Acid fast bacterias. There's a small, I guess, community of those bacteria that require that type of staining. Rod-shaped bacteria are some that are very difficult to stain, but they can be acid stained, acid fast staining. Um, Conditions for survival, again, anaerobic bacterias. Okay, so we talk about the conditions that's needed for a bacteria to stay alive. If it's in bacteria that are anaerobic or if they're in an oxygen enriched environment, they flourish very well. And in anaerobic environment that they won't thrive. Um, you have temperature loving bacteria, okay? You have the psychrophiles, the mesophil, and the thermophil. Psychro means that they like the cold. Meso is moderate temperature, and the thermophils, which are heat resistant and they love warm temperatures. Um, you have bacteria now that are multi-drug resistant organism, or MDRO. Uh, MRSA is being the most common that we know, is methicillin resistant Staphylococcus aureus, a huge problem in healthcare, very difficult to treat. Then you have vancomycin resistance and things of that nature and so forth. Along with microorganisms is you have viruses, okay? Viruses have some of them have a protective coating, some of them do not. Depending on which or the other can become the difficulty to treat or to destroy in our processes. The most common known virus that we know is HIV. Okay, that one everyone knows that HIV is a virus, human immunodeficiency virus. Okay, it's in the name. Hepatitis is another virus that plagues us. And we deal with all these viruses in central processing when we're working in the decontamination area. We're not told what the patient has or what is their problem, but we have to protect ourselves and use standard precaution in thinking that every patient that comes into the hospital is infected with one or all of these viruses and microorganisms, excuse me. Okay, so we protect ourselves as best possible from all of them. Okay, doesn't matter what it is: COVID, HIV, hepatitis, tuberculosis, it doesn't matter. We use standard precaution and treat it as if every patient had one or all of these symptoms or diseases. Okay, along with microorganisms, you have a fungus. Okay, so fungis. I'm a fungi. Um, and then you have prions, which um, I'm not going to say we don't deal with it in the United States. There are very few cases in the United States with prions. But when we deal with prions, it's not something to play with. It is 100% lethal. Okay, there's always a kill rate. It's not a treatable disease. One being, and it's not considered live. It's not considered dead. It isn't. They're abnormal. Um, One of the best known is CJD, which is Creutzfeldt-Jakob disease. Um, if we're using our instrumentation on a patient such as so, um, most likely out of not, that instrumentation is destroyed. It is exposed to high um, uh, time and temperature in sterilization to destroy the organism, the microorganism, and most likely those instrumentations are destroyed unless the IFU of the instrumentation gives you specific instructions on how to clean and reprocess those instrumentations. I've never had to deal with it, thank God, knock on wood, um, but I do know about it, okay? Um, Controlling and eliminating microorganism, again, that's where our disinfections and sterilization processes come in, where our cleaning practices come in to reduce the number of microorganisms on a surface or an object. We practice this at home when we're cleaning and wiping down tabletops. In central processing, it's environmental cleaning. Uh, it's environmental controls with positive and negative pressures and airflows. It's reading labels of disinfectants, letting you know how much contact time is needed to kill certain bacteria and viruses. And then our cleaning agents, it's how long should we soak our instruments for, our devices, how much scrubbing is required. That's where time, temperature, condition, and killing agent comes into play. Okay, because not every soap, not every detergent, not every disinfectant works against all works against all microorganisms. There are specific ones that work well with others and not so good in others. Um, so, in concluding this chapter, again, it's about 25-page read. I recommend that you do read it and that you understand it very well. Is that we assume everything is contaminated. Okay, the moment a set is open, it is contaminated. The moment that you wake up, you as a human being are contaminated. We have natural flora. Well, I spoke about that just now. We have natural bacteria that are beneficial when they're on us, but my bacteria may not coincide with what your bacteria is. Okay, the bacteria count in my mouth is different from the bacteria count someone else's mouth, so forth and so forth. There are general microorganisms that live on our bodies that everyone has, but the numbers change, the numbers fluctuate. Um, from person to person, from state to state, from country to country, from patient to patient. Okay, the natural flora on a healthy individual can become an opportunistic pathogenic flora on a patient that is immune suppressant. Okay, so as sterile processing technicians, we have to understand that we treat everything as being contaminated and we protect ourselves against all the elements. All right, guys, thank you for joining me. I hope you found this helpful in one way or another. As always, stay true to yourselves, keep it 100, and I see you guys next time when we tackle chapter 5, which is regulations and standards. Peace.